I've never heard anybody say "Como vai você?" and then someone say "Vou bem, obrigado." I mean, what do they say? Tudo bem, tudo ótimo. That's what they say. You know, so what you learn in school is so different. You know.
Yeah. Como ça va?
Como ça va?
Como ça va? That's French, of course.
Yes. Oh, he's multilingual. He speaks 8 or 9 languages, Richard. So.
Oh well, you know, I speak a little tiny bit of about a dozen. I make it a point to learn how to say thank you and you're welcome in as many languages as possible.
Yeah, so well, I got a master's in linguistics. So the idea, people think when they think linguistics, you're a polyglot, which means you speak lots of languages. Yes. So when they say that, I know they're going in that direction. So I come back at them with this. I go, probably about 15. They go, oh my God, 15. I go, yeah, C++, Lisp, Prolog, you know, Basic, ECL. And they go, what are you talking about? Well, computer. I said. Then I finally said, no. Linguists, we study the structure of language. We are not polyglots. We're not translators, and so it's, you know. So I get that all the time. But I did choose Portuguese sort of as my language. But man, it's not an easy language. It's much harder than Spanish because it's older and it's got a lot more forms from Latin, and. The conjugations for the verbs there's 76 conjugations for every verb in Portuguese. 76.
Wow.
English.
That was the interesting thing I found in Spanish. I learned more about English grammar in Spanish class than I ever did in English.
Yeah, that's true. That's true.
Yeah. You know, past perfect, future perfect, all these tenses that I had no idea there were such things.
Yeah. There's not much to play around with English.
Yeah, the system of English is easy. The vocabulary is enormous. It's the biggest vocabulary in the world, meaning number of words. But the thing
we steal from every language.
Yeah, well, everybody does. 40% of English is French. But the thing that really is hard in English for foreign speakers to learn are what we call verb particles. Get in, get out, get up, get down. Yeah. Those things are used everywhere. They're split up. And look, just the word get and put any preposition after it. Get off. I mean, that even has 2 very big different meanings. You know, you have get in, get out, all the prepositions that English uses in verb particle forms that make the verb completely change. And that's hard. And the hard thing in Portuguese are the conjugations, because they have future subjunctive, which they don't have in Spanish. They have all these subjunctive forms. When I first heard that, and then the other thing is, of course, is gender. Everything has a gender, which is really old. It comes from old languages where they gave souls to everything, from rocks to trees, and they all had souls and they all had genders. And so Portuguese is hard to speak it well. Yeah.
Okay, well, I'm supposed to be in Bob's session, so I'm gonna depart and say até amanhã.
Hasta mañana.
Oh, mañana is Saturday, right?
Let's see here. How do I get out of here?
Yeah, I was talking to Hugo that just real quick. I was talking about suggesting that you do your first talk in Portuguese and record that, so that we can put it together with the other 2 sessions, so that we'll have those recorded. So I talked to Trish about that. I think that would be a good idea, because I was asking him why not do it, because I think I don't know how many people we'd have here today, but we have lecture 1, 2, and lecture 3. Those are recorded, and we don't have lecture 1, which to me was like the best of all. I mean, it's better than than a great movie I've seen. I mean, it was so inspiring. I cried. But I did mention to her, so she may come to you and ask you to record that first talk in Portuguese. I just thought it would, you have the 2 recorded, but you don't have the first one. And if you don't have the first one,
I was wondering, I was wondering what they're going to do with that, because since we don't have our one, I'm not sure. How can they use it
Well, don't worry.
But I'm okay with that.
I volunteer you.
Okay. You all told me, yeah.
Okay, but yesterday my favorite words. Here are my favorite words from yesterday. Handomic.
Yeah.
I cannot believe that's a word because it's really totally borrowed from English, right?
It's a mix. It's a mix.
Yeah, no, it is. But they took the random word random, right? And then they brought it in and totally made it Portuguese, which is great. Yeah. But I never heard that. I was like listening to Randômica. The other one was Clusterizando. I heard that and I almost fell off my chair. It's almost like a Brazilian. I hear Brazilians here in Florida, in the United States. Here's a Brazilian speaking Portuguese in the United States. Oh, está esnoeando, eu vou parquear meu carro. I mean, nevando, eles falam esnoeando, cara. I mean, I can't speak Portuguese right because all the Brazilians in the United States, they borrow words. You can never hear a Brazilian ever say one sentence all in Portuguese. It doesn't exist.
Yeah, one of these days, I heard a word that I never heard before. It was called drivando. So it's driving, but directing, you know, like.
Oh my God, drivando.
One that is very common here is mergeando code, you know?
Yeah.
Code base.
What's
merging.
Oh,
you know,
my God.
And you say mergeando.
Oh my gosh. Oh, you know the one that the Brazilians borrowed and then used it way different, completely different. It's upgrade. You know, in English, we Americans use upgrade for software, pretty much only software, or like maybe your phone, but Brazilians use it for, eu vou fazer upgrade no meu look. What? I mean, if you went up to Americans and said, I'm going to make an upgrade in my look, they're going to go, oh, is look a new program? Is it a program? What's the program? And you hear that everywhere. Eu vou fazer upgrade no minha vida, cara. Eu vou fazer. Whoa! I mean, they took it and they use upgrade everywhere.
Yeah,
it's so
one
thing
that surprised me was the word notebook. I always thought that notebook was actually laptop, you know. But one of these days I came to know it's not really a synonym for laptop.
Yeah. Well, people will use it. A notebook, if they do use it, is more like a netbook.
Yeah.
Well, no, it's a paper thing. That's the common way. Yeah. But you can say or notepad, yeah. But notebook, they can use as a computer. It's used very little. It's laptop.
Yeah.
Netbook, because a netbook means it doesn't have all the programs. It just runs everything on the internet. So those are used. All righty, we're almost up here.
I bet that David Willock must have several of these words here.
I can't show my T-shirts. I had a new T-shirt today show, but now I can't do it. So it's not Brazilian. So I was going to wear work, you know, samba yes, work no, but I thought I'd probably get in trouble. So we're not supposed to use those kind of things. But you know, Brazilians are. I always say to people that, well, I'm doing it because of the Brazilians. It's part of their culture. So, okay, folks, I guess we're ready to start. We are recording. I want to welcome everybody today. This is an extra day we're doing because it turned out that the first day's English session they had some technical problems, and they decided that they were today going to add an extra session and 2 sessions in English. We've been doing this in Portuguese. Hugo has been doing it along with Artu, and but today it's going to be all English. And for those Brazilians who are here, that happen to be here, the first 3 sessions, the first session was done in Portuguese, was not recorded, but I think what we're going to be doing is re-recording that first session, so that those, if you are Brazilian, you will be able to see all of these lectures in Portuguese. But today we're going to be doing English, and I'm going to pass it over to Hugo. Hugo is in Brazil. He's one of the people who've been working with the training team, and has been very kind today to do this whole thing in a non-native language, but he speaks English very well. He told me he learned it from sitcoms and Seinfeld. So if you hear any, phrases that sound like Seinfeld, you'll know why. But I will turn it over to Hugo. And if you have any questions, make sure you type them in. Ahtu will be watching them, and Hugo will be stopping now and then to check if there are any questions. So take it over, Hugo.
Yeah. Thank you so much for the introduction, Dave, and I apologize in advance in case I use an improper word like David mentioned. But I'm here to present this first hour of the workshop, Mastering the Relational, ROXIE and Regressive Realms with ECL. So today we are having like 2 sessions in English. My colleague Bob Foreman is presenting one session on room number 1, and I'm presenting room number 2, but the content is the same. Feel free to switch over if you will. There might be some limitation on the number of attendees, but the content is the same, okay? So what's the agenda for this first hour workshop? So we are going to basically talk today about the relational realm of ECL. So we are going to be talking about relational data, basically, right? And relational data, first of all, we will talk about the concept itself, but in ECL and any other, like many other database management systems, you can think about relational data from 2 main perspectives or paradigms, right? You can think about a denormalized architecture, which is what we are going to talk about in the very first part of this workshop. And then we will going to see some queries about it, how to use that architecture. And of course, we can also have relational data in a normalized structure, which we will also cover by the end of this workshop, right? And the reason why we are giving much more emphasis on the normalized structure at this point of time is because most of the introduction courses in ECL focus on the normalized database structure. So here we are going to push a little bit forward or move a little bit forward and look at the same data structure, let's think like that, but from a denormalized point of view. Very well. So when we, if you want to join us and follow me through the demonstrations and exercises, just a little reminder, we have a training cluster running on the cloud, so you can join our training cluster using this IP address and this port number, either if you're using ECL IDE or VS Code. Okay? And all the code that we are going to use on this workshop, along with the slides, are available on the landing zone of that cluster. Okay, so you are welcome to either download the code, the slides, or even the training data that we are using here. Okay, feel free to take with you so you can practice afterwards as well. And just FYI, the data that we are using is all fixed length records. So in case you want to try the exercises at home, remember to spray the data using the record lengths specified on this slide. Okay. Just remembering, we are going to talk about relational data, and we are going to deal with a set of hierarchical data in a 3-level structure. Okay, so we're going to basically be talking about people, their properties, and the text data from those respective properties. Okay? That's the database structure you need to have in mind when we are going through this workshop. Okie dokie. So when we talk about denormalized data, or let's step back a little bit, when we talk about relational data, we are talking about data where one entity might have, its attributes or associated entities on another record, right? Somehow those 2 records may have a link in between them, which could be perfectly a specific field on that record or data set, right? And we could be talking about, like I just mentioned on the previous slide, a person and its properties, his or her properties, and its text data, right? And one way we can put all that data together is by using a denormalized structure, right? And a denormalized structure would look like exactly what this slide is showing us. I could have, for instance, the beginning of a record with a people record, right? And right next to it, all the entities or attributes from that main entity. For instance, the vehicles that that particular person owns. So in that case, that person could have, for instance, 3 vehicles, right? Right next to it, we could have the property, one of the properties that that person owns. And along with that, the text data records for that specific property. If that person has another property, it would show up right in sequence, once again, along with all the text data records for that last property record, right? So that's what we would, refer as to a denormalized data structure. There are some benefits in using it. For instance, once you access your main entity, you have right access to all the attributes or associated entities with no major data manipulation. But there are also constraints. For instance, if another person owns the same vehicle, or another attribute that's shared between 2 persons, you would have a lot of duplicated data on your database, right? Because the vehicle record would show up here, but would also show up on another person owning that same vehicle, right? This is the same thing for the property and text data. Those records could be duplicated for another person. Also, the access here is sequential, meaning that if you want to access a particular text data, you first need to navigate through all the people records until you get to your target person, and then nail down up to the text data you are, looking for. So there is some benefits, some pros and cons using denormalized, but one other or alternative paradigm is using the normalized data structure. In a normalized data structure, you basically have separate tables for your main entities or attributes. This is exactly how, for instance, the LexisNexis data Datasets works. So you have your Lexis ID as the main, as the main entity, or representing your main entity, which could be an individual or a business. And if you want to know what are the associated entities with your individual or business, you can just look at the associated data set, for instance, the vehicle data set, and search for the Lexis ID from that particular individual and get the vehicles associated with that specific person. Same thing for the phones, for the address, and etc. Some benefit here, you have much less duplication of your data, because same vehicles would be deduped, let's say, in the respective vehicle data set. But on the other side, you always have to remember you don't have direct access to your attributes or associated entities. You usually need to deal with 2 data sets in order to get all the information you need from that particular person or entity, right? So 2 different data structures, both can be managed in ECL. The normalized structure we have already stressed it on the introduction to ECL courses. So today on this workshop, our focus will be on the denormalized data structure. Okay, good. Any questions so far? No? Okay. Very well. So when we talk about the normalized data structure in ECL, how does that look like? I would say that the main or the most common structure you might see in ECL when you're talking with when you're working with the normalized data is what we call a nested child data set. Okay, it's actually a child data set containing your associated attributes right next to your main record pointing to your main entity. Okay, and what are the elements we leverage from the ECL programming language to make that happen? I would say the three ones we are seeing on this slide. First of all, we make a record structure where we point a data set as a field, which is what we call nested child data set anyway. And then we need to populate that data structure using the DENORMALIZE function associated with a specific transform logic. Okay, so those are the three main elements we will leverage to make that happen. And how does a child data set record structure look like? So to get there, first let's remind or remember how does a normalized record structure look like, right? We have here basically the two main elements we need to define a data structure in ECL. We have a record structure right here at the top where we are listing all the fields and its respective type that will, structure my data set. And down here below, I have a data set declaration where I am associating my logical file with this record structure, right? So this is our simple normalized record and data set definitions. When we are going to work with the normalized record structures, we need to think about two different record structures. First, we need to think about the child record. So how does the child record will look like? What are the fields contained on that child record structure? And secondly, we will have the parent record structure, which will own, if you will, the child record structure. And what is the field linking both of them? This one right here highlighted in yellow. So what we are saying here to the compiler is that one of the fields of our parent record will have a specific field called children, which will actually be a data set itself whose structure will be the child record. So if you look at those two record structures, you can see some meaning on that hierarchy type of structure. You can see that the parent record has an ID, an address, a code for city, states, and zip, a postcode, and a number of people field. And then nested into that structure, you have another data set which will contain a person ID, an address ID, a surname, and a forename. So if you look at those fields, you can think that probably this data set will nest all the people or all the names of the individuals sharing the same address. So within a single address record line, you will see all the names of the people, or individuals living on that address right next to it. Okay, that's the nested child data set record structure. But how do you get there? How do you make your data to flow from your original two data sets into a single nested child record structure? That's what we are going to see now with the DENORMALIZE function. But before we get into the DENORMALIZE function, I would just like to remember or remind you about what the transform structure looks like, because the transform is actually the engine that will make or populate my nested child record structure accordingly. Okay, so here is the syntax, or the generic syntax from the transform structure. What I have here, of course, is the keyword transform, and I have a parameter that I need to pass for that transform function. Remember, any definition in ECL that receives parameters are considered a function. So here I have a transform function receiving parameters. In this case, it will be a record from a particular record structure, and I will transform that record into a different format using this result type, which will also be a record structure, but in the format of my outcome. Inside my transform, I have all the transformation logic. I can specify field by field on my output record structure what I want the transform to do. I might want to combine fields. I might want to change the value of the fields, or I might want to just keep the field value as is. All of that is under my responsibility to define. And of course, I have the AND statement to finalize the list of transformations I want to encapsulate on my transform structure. Okay, that was just a quick review of the transform structure, because we need a transform to actually denormalize our records. And how does the denormalize function look like? Basically, in a denormalize function, we need to take a parent output or a data set, if you will, but it will be the parent data set. We need to pass the child record set. In other words, a second data set, a second record set, but it will be the child record set on the final data structure. We need to specify a condition associating the parent record set with the child record set. And finally, a transform to tell the function how to manage the records being moved from the child record set into the parent record structure. Okay, so you might think of denormalize as a specialized form of join, because we are working with two separate data sets. We are passing a condition to call a transform, right? So you might think as a specialized way of join, but there is a very important difference that I will outline when we get into a practical example. Okay. Very well. So how does the normalize actually is written or inserted on your ECL code if you need to denormalize two record structures? And here is a very conceptual example that can give you a glimpse of how that looks like in a real code. So suppose that I have two record structures, a parent and a child, and I have here 3 records for the parent data set and six records for the child. And I want to nest it, or let's say I want to denormalize these 2 records, such as the child fields will appear right next to the parent file. Okay. So first of all, I need to specify, usually as any other transformation I do in ECL, how does the output record structure look like? First, I need to specify what kind of structure I want as an outcome of this denormalize function. And here, I'm just keeping the parent values, and I'm specifying 2 new fields, which will contain the child records. right? But I initialize them as empty strings because the denormalize need the fields to pre-exist before they can be populated. So first of all, I establish my record structure with empty fields, and next I use a table function just to populate my parent record structure. So I'm passing here on this table function my parent file into my output record structure, but now having two additional fields which have been initialized with empty strings. So now I have what I need in order for my normalize function to actually take place. Okay. So that's what we have here highlighted in yellow. Here is actually where I'm passing the normalize function. And as a first argument to that denormalize function, I have the parent records, which now already have the appropriate fields to receive the child. I have the child file itself. For the first time, I'm passing the child file. The condition that will link or match the two record sets. So here I'm saying that the value 1 from the left record should match the value 1 from the right record. And every time this happens, I call the denormalize function, transform function, passing the left and right records in a counter. Okay. And then on the transform function, I specify the way I want the child record structure to be filled or populated. So here I'm passing a left record on the myoutRec format and a right record using my initial record structure, right, for the child record. And here I'm just populating the two child fields using a conditional if. So on the first iteration, I will take the value 2 from the right record. So in this case here, I will take the second column. And in the second iteration, I will take the right value from the second field, right? So in each iteration, I will be taking either the left or right value from the child record set. And all other fields, for instance, the parent fields will already be there. So I can just declare self is defined as left. So I can maintain the parent value fields that were already there. Okay. So that's a conceptual example, but in how does that look like in a visual format? You can see here that we have on the very left the original parent records only, right? It's repeated several times because it's showing how the normalize function works. But here I have just the original parent records. And what I have here as an empty column, actually two empty columns, is the outcome of my table function. So right after I passed my table function to that record structure, I created or initialized those two fields as empty strings, right? And as the denormalize function started to work in that, or started to parse that parent record set, the first thing it did was to check if the value 1 for the parent record matched the value 1 from the child record. And until that condition was maintained or was met, it was taking the value 2 from the right record and nesting into the child record structure, as you can see here. So Z and T came over to here, and once all the value 1s stop matching the value 1 from the first record, then the denormalize function move it into the second row, in this case here B, and starting matching the value 1 from records 3 and 4 from the child record set. And then it nested Y and S, and so forth with C and X and W, right? So this is a very nice diagram that shows you that even though the normalize looks like very much as a join from a syntax point of view, it is actually way different in a functional way, because a join would iterate through the left record set for each matching condition, whereas the denormalize function persists the parent record until all matching conditions are reached or parsed on the child record. And only after the matching conditions are done for that first parent is that the right record or the left record will actually move to the next one and then validate its condition with the right record set. Okay, so that's a very important distinction between the normalize and join, even though you can think of it as a specialized form of join. All right. And just a final example before we actually do the normalize ourselves. What if I want to nested my record structure, actually in my parent record structure? Let's say I have more than just one record to nest below my parent record. In this case here, I'm limiting my number of child records in 5. So the main difference here would be to, instead of listing my fields as standard fields on my output record structure, I'm actually specifying that this children field will be a data set indeed. Okay. And once I have my parent record and my child record, I can use then a project to make or populate or initialize the output record structure. And why using a project here is a good thing, because remember, if I'm using a table function, I need to define standard values for all of my fields, or for all the fields that I'm adding on my record structure. And instead of specifying default values for each field that I'm adding for the children record set, if I use a project with a transform, I can just reference my entire child record as a single field, which is actually is, and then passing these opening and closing square brackets to tell the compiler that all the fields that I'm adding on that child record structure will actually be initialized as empty. Okay, so that way I don't need to specify each record or each field individually and define them as empty strings manually. I can do I can pass a single instruction with all the children fields using these opening and closing square brackets. And finally, the denormalize function would be called very similar to what we saw on the previous slide. I'm passing here the output of my transform, my children records, a condition to match the parent and child records, and a call to the transform function. And the key thing I want to highlight in this example is that for all the children records to appear actually nested underneath a single parent record, you must use this incremental type of syntax, where on each transform iteration, you are actually maintaining the child record that's already there on the output record structure, and just bringing in the new child record that it's coming from the transform or the denormalize function. Okay. Otherwise, if you don't use this kind of logic, you might end up, if you don't pass right, for instance, here, you might, or let's say, if you don't pass the left children here, you might end up with a record structure where just the last child record will appear on your nested child record structure. Okay, so remember to always use this type of incremental logic when dealing with nested child data sets. Okay, folks, but enough with the theoretical examples, right? Let's switch over to our ECL IDE and see how that actually looks like in real code. And I'm going to start with the two examples we have here on those, few slides I've just showed you. You guys also have these examples with you if you download the mod file from the landing zone. And right next to it, we will normalize our data sets, right? Our 3 data sets that we are using as an example in this workshop. And for that, we are going to use this BWR, which is already available on your relational folder from the repository that you can download from our training cluster as well. Okay. So let me switch over to the IDE, and I will also take the opportunity to check if there are any questions from the audience. Doesn't look like so far. Okay. Okay, so I'm sharing my screen. Let me just hide this one. And what I'm showing here on my ECL IDE, folks, is actually the code that we saw on that first conceptual example. Okay, so you can see here that we have our parent and child record sets, and I'm just going through that same, table function where we created room for the children, and the denormalize function where I specified the logic for populating my child fields. And if you submit this code, you will end up with a record structure like this, where you have your parent records on the left and the 2 child fields on the right. Okay? So I'm just nesting the child records right here. But the usual way of doing the denormalize is actually on the next example, the nested child example. And here is actually where we are denormalizing a set of individuals, in this case myself, my wife, and 2 other unknown folks, and associating them with specific addresses. And look at that. This is the linking field between the 2 records. I have here a number that links the person from the names table to the address from the norm address table. Okay, so in this case, myself should appear with just 1 address. My wife should appear with 2 addresses. I'm not sure why she has 2 addresses. And then Mr. Nobody should have no addresses, and Mr. Anywhere should have 4 addresses. Okay. So if we normalize this record structure, this is how an intermediate record set would look like in a denormalized process. First, we added the two child fields, and we initialized them either as zeros or empty strings, right? We created room for the children. And then on a second step, this is where we see, the records being nested right next to their owners. And of course, in the ECL IDE, you will see that on a XML format, But if you switch over to the ECL watch, then you can see all the parent and child records nested accordingly. So if you switch over to the ECL watch tab and click on the nested child dataset, you will see here the parent records and all the child records nested right next to it. So remembering, I have my own address, a single record, single child record. My wife has 2 for some reason. Mr. Nobody has 0, and Mr. Anywhere had 4 addresses. All of that was achieved given that we have this linking field between the two record sets. Okay. So how does that look like in real life? And that's where I'm going to invite you all to join me and denormalize our 3 main record structures. So we have a people data set, a property data set, and a text data data set. So for those who have taken the advanced ECL class recently, may recall from those examples. And just to refresh you all, I'm sharing that the record structures on my screen. So here I have file people. Usually, as we are used to it with the first name, last name, middle name fields. We have the property record structure containing attributes from each property, and the text data containing attributes from each text record. Remembering that the text record are associated with the property by the property ID field, and the properties are associated to the persons or to the people data set via the person ID field. Okay. And how do I denormalize all those 3 data sets? You can do it quickly by using this BWR relate ECL file that comes within the relational folder of the repository we are sharing on this workshop. Okay. So if you just switch over to the BWR relate, let's go over here, you will see that logic I just talked about. And first, we are creating room for the children. And remember, I have to do this in 2 phases in this example because I'm dealing with a 3-level type of hierarchy. So first, I will denormalize property and text data. That's why here I'm just creating room for the text records, right? And I'm using a project as I highlighted on my previous example. Again, the incremental type of logic on my text recs fields. And here I have my denormalize. And I'm denormalizing my properties with my text data, linking them via the property ID field, and then calling that transform function that will do the denormalizing actually. Once I'm done with that, I next need to denormalize property, people, and property and text data, right? So that's where I will use, once again, a project, but this time I'm just creating room for the property records. And here I have my denormalize between persons and properties and text data. My linking field in this case will be ID and person ID. And then I will call the transform, which will populate the property fields in an incremental type of way. And it will bring with them all the text data records already nested on the first step up here. So if you guys just submit this PWR, you will end up with a structure like this, where you can see for each person, you will see the prop records here again on an XML format. And if you scroll all the way to the right, you finish that record containing all the attributes from that person. If you want to see a better view of it and not on an XML format, you can just go into ECL Watch once again and select the record structure you want to you just denormalized. So here you can see our old friend Petronica Spock and all the properties that she has under her person ID, and alongside the property records, you have all the tax ranks right next to it. Okay, so this is how a nested child record structure looks like in ECL. You have all the attributes from your main entity all contained on a single record set and all nested right beside the parent record, in this case, Petronica Spock. Alrighty. Okay, so let me now switch back to my slides. Let's stop my screen sharing. And at this point in time, some of you might be thinking, okay, so we have spent like half an hour here talking about the normalize function, how to denormalize in ECL, but how does that actually help me on my day-to-day basis? So one important thing, and if I could ask you what's the main finding or information you need to take from this workshop, this slide and the next 2 or 3 will tell you, or will try to show you, what is the main advantage of a denormalized record structure in ECL. So whenever you denormalize or work with a denormalized record set, like this, where I'm working with people, property, and tax data, whenever you are working at the level of a child record, let's say tax data, all the fields from the parent records are always in memory. So that means whenever you are dealing with a child record, you don't need to look forward the fields associated with the parent. You don't need to do another disk access to find a field belonging to a parent record. Okay, so that's one first advantage. Secondly, whenever you are working on the level of the parent, you may only reference the set of child records associated with that parent record. And that's a very interesting feature of ECL, because if you do a question like this, if you ask for what is the property with the highest value of text data, and you do that question on the level of the people record, instead of giving you a single property with the highest text data value from all your data, from all your data set, it will give you the highest text data from a property from each person. Okay, so this behavior is what we call implicit dataset relationality, which comes by default whenever you are working with nested child datasets. And those two features combined can give you a lot of power when working with, relational queries, which is what we are going to see next. So for instance, in this data set we are working, suppose that you need to do a query like this. You need to look at all the properties you have in that data set, and you need to query what properties have or ever had 3 or more bedrooms. And why I'm emphasizing the ever had here, because a property record can tell me or show me how many bedrooms this property has today, but the historical composition of that property is actually tied to the tax record from each year. So if a particular property at some point in time had 3 bedrooms but doesn't have it no longer today, maybe because it came under some kind of reconstruction, the tax data record will tell me if at some point in time that property had 3 or more bedrooms. So this is a type of query where we need to traverse not only the property records, but also the tax data records to actually fulfill the request. And if you need to work with a denormalized record structure in this scenario, things become pretty easy. So I usually say it's only a 1-line type of query, yeah. But you're seeing here, okay, Hugo might be crazy because I'm looking at like 4 lines of code, but I'm just adding here an import and renaming my record structures because I want to reutilize some code, and I want to make my code cleaner, so I'm renaming my record sets. And if I want to be actually pretty, correct here, I would create a function to compare 2 values, just because this type of query could be reutilized in the future if I want to query properties with 4 or more bedrooms, 5 or more bedrooms, right? But actually, all that structure that I have included here could be on the same ECL file. But the real logic of the query is here on a single line. I am filtering all the properties and checking if the bedroom fields is greater than 3, or filtering all my tax data and checking if the bedroom fields is greater than 3. And I'm just counting the number of records that are left after those filters are applied. So what I'm trying to highlight here is that once you have a denormalized data structure, a great portion of your queries become simple filters. And in comparison to joins, those operations can become pretty attractive. If you want to do the same query using a normalized approach, where you actually have separate data sets for property and tax data, and if you want to keep with the same type of parametric approach we use it on the last query, creating this function to compare 2 numbers, I might not have a very long code, but it's a very computing process consuming code. I need to do the same filters once again for property and tax data, but then I need to remove duplicate entries for my tax data record set, because remembering each property might have 1 or more tax data records. So I need to do a dedup, which I can previously sort or group. Sort would actually be more compute consuming than the group here. And then I need to join my filtered data set or record sets and link them via the property ID field and using a full outer logic, which is also preventing me to optimize my join using local type of logic. So even though the extension of the code is not pretty impressive, if you look at the graphs, that's where things become pretty scary. Because if you look at the normalized graph, you are basically just filtering, discreting a filtered record set. and that's all. On the normalized situation, you actually need to discrete text data property, group then or sort, and then do your join and then count, right? And actually, if you do a sort dedupe here, you will see some spill happening on the cluster that we are doing our training. So things could become even worse. And when you look at the graph, you can see that even though compile time hasn't changed too much between them, the work unit times and graphs can vary quite a lot. Okay, so that's the main outcome of all this discussion, how the denormalized queries or the denormalized data structures can help us actually to perform better when doing complex queries. Okay, and as a quick challenge for all of you, I will leave here 2 additional queries that you can try now that you have your denormalized data sets. You can try by yourself afterwards and compare, what is the performance between a denormalized record structure and a normalized record structure for the same goal. You guys will be pretty impressed with the differences. So this is the second query, where I'm asking you to calculate the aggregate property values for all properties on small streets. And this is the solution in case you want to compare afterwards. And the third query will ask you to calculate the assessed total value from the most recently reported text data record for the most recently acquired property that's not an apartment. So quite a challenging question, but if you use the denormalized record structure, you guys will see that actually it's not that complex when you're working with a denormalized record structure. Okay. But okay, I have seen the benefits of using denormalize. I have seen actually how to use it. But let's say I want to come back to my normalized data sets. How do I do that? And we have the normalize function to help you with that. And we'll see the normalize function in a couple of different ways, starting with leveraging the number of children records, the child records we have on our denormalized record structure. Okay, and at the end of this demo, I will show you an even better way to do a normalize operation. So how does the normalize syntax looks like? It's way simpler than the normalize, I would say. You just need to pass your denormalized record structure or your denormalized data set, one expression that will also represent the number of times you want to call your transform function. And the transform function is what will establish the logic for extracting the child records from your parent record set. Okay. So going back to our conceptual example that we denormalized it first, just remembering that's how the data set looks like now that we denormalized it on the first part of this workshop. For fields, 2 coming from the parent, 2 coming from the child record. And the first step in a normalized operation is to extract the parent records, which is eventually very simple because you just need to use a table on a vertical slicing and pass your denormalized data set against your output record, which will only contain 2 fields now. So with that, you have your parent records extracted. And if you want to extract the child, that's when the normalize function comes in, because you just need to now pass inside the normalize function your denormalized data set and call the transform function 2 times, because that's the number of records, that's the number of fields you have on your child record set. Okay, so how does the transform function looks like on a normalized situation? You need just to specify what will be the logic for extracting each field of your child record. So value 2, for each iteration, you need to bring, left C value to 1 or C value to 2. Remember, those are the 2 child fields. And for value 1, you just need to take left value 1. Okay? And of course, this transform logic will change depending on how you structure your denormalized data set. For our real example, where we matched people and address, sorry, this is just a functional diagram showing our theoretical example, where we have here the parent records, and here we are extracting the child. So this is just a functional diagram showing how each of the child records will be extracted one by one using the transform logic demonstrated on the previous slide. But if you want to actually see how that normalize function works, we can go back real quick to our 2 examples. And let me just stop sharing my screen, start sharing my screen. Okay, it might take a few seconds. Okay, so in our real example, where we were normalizing people and addresses, how can we do that with normalize? So a first form I'm showing right here, when I'm passing my denormalized recs, and I'm specifying the number of times the transform will be called from a field, exactly the number of child records. And here is how my transform would look like. Okay? I'm just extracting the child record from each counter value that represents the number of times the transform was called, which comes from my number of rows field. This is the first form. If you don't have a number, a field capturing the number of child records, you can basically use a second form of normalize, where you point to the child field on your denormalized data set, and it will look at the number of child records you have and call the transform accordingly. But the real easy way of doing a normalize recently has been added to the project capability. So today, if you want to normalize something, you can just use project and pass your children records over your children record structure. You will have your normalized data sets once again real quick. So let me just show you. If I want to do the first way, this is how my childs would look like. Second way, third way, and project way, all looking like the same. Okay. So let me just stop sharing, and to conclude this presentation, I want to emphasize working with the normalize and normalize record structure is actually something tied to your own needs. You might find easier to work with the normalizing depending on your query needs. If you're working with too many attributes, in every operation, you might think about using the normalized record structures so you can take advantage of the implicit dataset relationality. But if you might be working with queries where your end goal is to actually find a single record and the attributes associated to it, you might think about going with a normalized data structure, because the joins on that condition will not be too computing consuming, I would say. Okay, so that's it for the first part of this workshop, folks. Again, it was a redo from the first day in English, and I hope you guys have enjoyed it, and might have learned some additional things in comparison to the first day taking it once again. And that's it for today. I'm going to give my microphone back to David Huster, if you're still there.
Yes, I am. Thank you so much. Greatly appreciate you stepping in today, coming in, doing it in Portuguese, now in English. I didn't hear any Seinfeld phrases, so that was really good. But really do appreciate you coming in and doing this. A lot of people were coming to the workshops before and couldn't get in, so it was decided that they would do this extra day. And of course, Hugo has been working very closely with Robert and has been a point of teaching ECL in Brazil. And I've been told he hasn't shaved since the pandemic started. So, but his wife has approved, I think. Yes, it's a very fact. But we really do appreciate it. And if you do have any questions, or you can get in contact with them. Also, again, if you want to see this in Portuguese, that will also be available. And Hugo will be recording the first session in Portuguese, and we'll have those available on the HPCC YouTube channel. So make sure you do subscribe to the YouTube channel, because we have lots of great videos there. And I want to thank everybody once again. This is our last day here, and hopefully next year, I have heard that they've actually reserved a hotel in Atlanta, so we would see everybody face to face. But I want to thank everybody who's gone through this and hung in there. I think it's been a great conference, and all the people who've been putting it together, who've been flexible, and even our audience being flexible, we greatly appreciate it. And hopefully we'll see each other in person next year. But do enjoy the rest of your day. Hugo and Artur will be around for the next few minutes if you do have any questions. But if not, you can always email them. So thank you very much, Hugo and Artur, who's in the background working away there. It's greatly appreciated, and congratulations. And forward we go.
Thank you so much, David.
Okay. Hugo will be here, so if you have any questions, just put them in the chat there. Okay? Artur will be there looking at them. I will take off now.
Thank you, David.
Okay, folks, any questions you might have, feel free to drop them on the public chat, and myself and Artur will take that. I am actually seeing a lot of folks from the Brazil office here, which is kind of surprising. So, yep. I'm seeing some comments about audio breaking up or failing. Artur, did that happen throughout the presentation?
It was okay. I could listen all the workshop. No problem.
Maybe the audio failures. Maybe the audio failures were on my translation, my dynamic translation.
But it was fine. I was able to hear the entire workshop without any problem or issue here.
Okay. Yeah. Okay. Good.
And I'm using the VPN. I forgot to turn off, but I didn't notice that it was turned on, so I could hear everything just fine.
I'm using VPN, throughout the entire conference, but I make sure I'm using the Atlanta VPN, because Boca I tried on the first day, and I was not able to actually see any streaming from the conference, so I just switched over to Atlanta. I'm using Atlanta since then.
Yeah.
Okay. Any questions? Maybe Christopher, Eberton, or Leonardo?
Don't seem to.
Eberton is typing. So David was telling me, I'm not sure if you were here at the beginning, but we might need to record the Portuguese session day 1 again, because that video is missing. So I might do it maybe by myself. I'm not sure exactly how they're going to plan that, but I might be able to record it myself.
It wasn't recorded in the first day.
No, the first day wasn't. Yeah.
But why didn't he just any technical issue, or they just forgot to record?
I think so. Yeah, I think it was I'm not sure if the requirements were communicated on that way. Arthur, with an H. Okay. Okay. Thank you, Eberton.
Thank you,
Glad
Eberton.
to see you here. Yep. We'll make sure we include you on any other workshops we do in the Brazil region. Okay. Yep. I think that's it then, Arthur. Thank you so much for helping with this day 4 workshop. And let's switch over to the conference then.